Hello, everyone. This is the lecture for section 5.3 and 5.4 for our Math 210S course, Other Trig Functions and Right Triangle Trigonometry. So in the first two sections of chapter 5 for our pre-calc material, what we were doing was basically covering the basics for our trigonometry, right? So in section 5.1, we started with angles and converting them to radians and degrees. 5.2, I showed you the very first two of our trig functions. Well, I showed you three, really, but I sort of mostly gave our energy toward sine and cosine, the first two, right? Turns out there's four more. I'm going to cover all the rest of them today, okay, in this video. The first thing I want to do is I want to go ahead and go back to the first two, or the first three, really, of our trig functions, okay? So if you remember, right, we have this, that sine of any angle theta, right, on a unit circle is going to be the y over 1, right? On a random on a random sized circle of radius r, it's going to be the y component with respect to the r, right? And if you used SOHCAHTOA, use that, right? It's opposite, right, over hypotenuse. All right, hopefully you guys remember that one, okay? All right, the next one, right? I'm gonna go ahead and color code these really quick. CAH, we remember that one to be cosine, right? So cosine of some angle theta, right, on a unit circle is going to be the x component with respect to 1 being the radius, right? On a random sized circle, it's going to be the x compared to the radius r, right? And if you use SOHCAHTOA, right, it's going to be adjacent over hypotenuse. All right. And then the last one that we had, this one, TOA, TOA, right? That was the tangent of some angle theta, right? And tangent of some angle theta was the y divided by the x component, right? And this one, it didn't matter what the radius was, right? Okay. And if you used SOHCAHTOA, right, then you had that it was going to be opposite, right, over adjacent. All right. So these were the three, and I'm going to space these out a little bit. These were the three that I kind of wanted to concentrate on, right? You guys remember that? There we go. I'm going to move just a little bit over. There we go. These were the couple that I wanted to really concentrate on, okay? Primarily because, right, all of the stuff that we have been working with really just required these three, right? Okay, so, you can do that. Okay. I don't know why it does that. Okay, there we go. All right, so this is where the SOHCAHTOA comes from, right? Sine opposite over hypotenuse. Cosine, look at that. Oh boy. Eventually. Adjacent, there we go. Adjacent over hypotenuse, right? You need to remember that one, right? And then TOA, the last bit, was the tangent is equal to opposite over adjacent. All right. There's three more. Thankfully, they are based off of these three right here, okay? So the first one I'm going to show you guys is this one, cosecant of theta. And that is going to be basically the flip of everything that's above it. So it's going to be 1 over y for a unit circle. On a circle of random radius r, right, that's going to be r over y. And if we use the acronym SOHCAHTOA, right, this is going to be the hypotenuse over the opposite. Okay, next one. For cosine, the flip we say is called secant of theta. And it's same thing, everything's flipped, right? So then it's going to be 1 over x, r over x for a circle of radius r, and this is going to be the hypotenuse, over the adjacent. There you go. And then the last one, right, is cotangent. Same idea. X over y, adjacent over opposite. Okay. So notice how these all work, right? And how they're related to each other, right? Sine, cosine, tangent are sort of like what we call the base three of the trig functions, right? All the other ones, they're basically modifications of sine, cosine, or tangent. Okay? That's it. That is it. So if you know how to at least relate those, right? I'm going to put a line through each one to signify their split. Okay? Then you got them. You got them. That's it. All right. There's a couple, though, that we can modify. Okay? And for this, I am going to need to sort of grab, I know I just made myself some space. I'm going to make myself some more space. Okay. I'm going to go ahead and, uh-oh. Okay. So here's some modifications that we can make already. Okay. We know that each one of these, right, for cosecant, it's the flip of sine, right? So that means that we can also rewrite this as 1 over sine of theta. Cosecant is also equal to 1 over sine theta, okay? And that's the case for all of these now, right? So then secant is going to be equal to 1 over cosine of theta, right? And cotangent, just like you would expect, is equal to 1 over tangent of theta. Okay? All right, we're getting somewhere. I'm going to actually give myself a little bit more room on the right-hand side of this one. Okay. So for this one, I want everybody to take a look at this. You guys see how this is y over x, right? Okay. Turns out y and x already had some designation, right? Y was sine and x was cosine. So tangent we can rewrite as sine of theta over cosine of theta. Okay. This is a rewrite. Okay. Cotangent was 1 over tangent, and we said it was the flip of the one above it. It was the flip of tangent, right? So we can rewrite cotangent as well as the flip of tangent, cosine of theta over sine of theta. There you go. Okay. These are very, very common rewrites of all of these trigonometric functions that we'll be using repeatedly throughout our study of calculus. Okay. All right. So let me get my bearings here. Minimize the thing that I wanted. There we go. Okay. All right. So what I want to do now is do some examples of how to actually work with these functions. Okay. And in particular, the thing that we're going to be using the most is how to compute these 6 trig functions based off of an angle that's been given. Okay. So for example, let's say I wanted to find all 6 trig functions of negative 5 pi over 6. Okay. So the 6 trig functions, right, are going to be this. It's going to be sine of negative 5 pi over 6, cosine of negative 5 pi over 6, and then tangent of negative 5 pi over 6. Okay, so let me first of all, let me grab these and move them over a little bit. Okay, and what I'm going to do is I'm going to bring a unit circle in. Come on, come on. Almost got it. There we go. Okay, so here we go. We want our angle negative 5 pi over 6. So remember how we did angles to begin with, right? If we go in this direction, right, that's positive. And if we go in the opposite direction, that is negative. So we want to go in that negative direction. We want to go that way, okay? And we want to go negative 5 pi over 6, okay? Negative 5 pi over 6 is not entirely one halfway across, right? It's just a little bit below, right? That is right here. So I'm going to do, this is my initial side, just like we did it in the first section of chapter 5, right? And we want to go, bam. So this right here is negative 5 pi over 6. We want to look at these two values right here. Okay? At this point, it's just matching them up, right? So we know sine is the y portion, so that's going to be negative 1/2. The cosine is going to be the x portion, so negative root 3 over 2. And then the tangent is going to be the y divided by the x. So 1/2 divided by negative root 3 over 2. Okay, and I'm going to put parentheses. There we go. Okay. Okay. Now, for the other three, right? Cosecant of negative 5 pi over 6. Secant of negative 5 pi over 6, and cotangent of negative 5 pi over 6. It's exactly how you think it's going to happen. It's going to be basically these. It's going to be these values. And we're going to flip them. That's it. Okay? So cosecant is going to be negative 2 over 1. All I did was flipped my answer for sine, right? For secant, it's going to be 2 over negative square root of 3. That's the flip of the one before for cosine, right? And then for cotangent, right, I grab tangent and flip that one. So it's going to be negative root 3 over 2 divided by 1/2, negative 1/2. Never got a negative on this one. There we go. That's simple. Done. These are my answers right here. Okay. So this section is going to be a little bit about how to use the unit circle appropriately, or how to navigate to find some answers off of it. Okay. What I got left coming up, quick checks. Kind of want to get you guys trying these. Okay. All right. What is really, really, really helpful, what tends to show up a lot when messing around with trigonometric stuff, right? It happens a lot in physics. It happens a lot in chemistry. That we need to find these values, right? And a lot of the values end up showing up on the unit circle anyway, right? Okay. So that's what I want to do. I want to get more used to just using our fundamental identities, the ones that I provided up above, okay, to find as many of these as possible, right? So I'm going to bring in my unit circle again. Okay, I'm going to cover up this one for right now. So let's say we had to do tangent to 45 and tangent to negative 45, okay? Hopefully you guys remember, right? Here's my initial side. Uh-oh, there we go. Here's my initial side out this way, right? Negative 45 degrees, well, let's do the positive one first, right? Is we go this way to 45 degrees. So we are looking at this one. Got it? So tangent of 45 degrees is also equal to root 2 over 2. Whoops. I need negative root. No, sorry. Root 2 over 2 on top divided by root 2 over 2 on the bottom. Got it? Okay. tangent of negative 45 degrees, right? We want to go now the opposite direction. So here's my initial side. I got to go down 45 degrees this time. So I'm down here this time. Yeah. This is the angle, or these are the two. These are the two values that I'm going to be working with now, right? So negative 45 degrees is going to be the y, right? So negative root 2 over 2 divided by the x, root 2 over 2. And it turns out both of these, since the top is equal to the bottom on both of these, this is going to be 1. This has got the same thing going on, but it's got a negative. So it's going to be equal to negative 1. Okay? Okay. Let's move right along. I didn't want to. There we go. Okay. I'm going to cover this one now. So we can do secant. Okay. Okay. We need 5 pi over 6, first of all, right? So let's grab our unit circle. We start here. This is my initial side. And we go to 5 pi over 6. So all the way till here. Right? This is my important point for this one, right? Okay. Secant, let me actually put this over here. Secant of theta, right, is equal to 1 over cosine of theta, right, which is supposed to be the x portion, right? I don't know why this thing doesn't erase frame. So my x portion here is negative square root of 3 over 2, so I need to do 1 over negative square root of 3 over 2. Okay. For secant of negative pi over 6, right? Same thing out this way, and I need to go negative 5 pi over 6. That's right there. So I need this point. Again, right, we need the x portion. 1 over negative root 3 over 2. Dunzos. Okay. So hopefully you guys see how important the unit circle is in finding any of these values. The unit circle is really supposed to be sort of like a shortcut to getting answers, basically. Okay. Let me make this nice and small so I can put it right there. There we go. Okay. Again, like I said, if you're doing anything in physics, if you're doing anything in chemistry, chances are what's going to happen is you're going to be able to use these trigonometric identities, right? And reduce very complex things into something a little bit more simpler to manage, okay? Case in point, what I'm going to have everyone do right here, okay? How do I simplify this, right? Or how do I simplify this, right? It's much simpler to work with something that's simplified down already, as opposed to something as complicated and convoluted as these two things right here. Okay, so that's what we're going to practice here. Okay, so let's use our identities to try to reduce secant t divided by tangent t, right? Secant from above, right, is going to be 1 over, secant is 1 over cosine, right? Divided by tangent is sine over cosine. Okay, and hopefully you guys, if you guys remember, right, the basic two of our trig functions are sine and cosine. So the very first thing that should come to mind when you do something like this, right, like these right here, at least for now, is to try to reduce everything back to sine and cosine. Okay. Okay. So when we have this now, right, this is equivalent to 1 over cosine of t, right, divided by sine of t over cosine of t. Now, I'm going to do it this way. If you know how to do it another method, you're more than welcome to do it so long as it gets you the same result. Okay. But what I remember from high school, right, is I can notice how I have a division of fractions here, right? Okay. I can grab my division of fractions and turn it into a multiplication so long as I flipped the second one, right? So that's exactly what I'm going to do. I'm going to grab the second one, 1 over cosine of t. The first one gets to come along for the ride, but I'm going to turn it into a multiple. The second one, I'm going to turn into a multiplication by flipping it. So it's going to be cosine of t divided by sine of t, okay? And what this reduces to, right, is this. What you guys can see is this, that there's a cosine on the top. Whoa, not what I wanted to happen. Come on, there we go. There's a cosine on the top. Here we go. There we go. I don't know why it does that. There we go. There's a cosine on the top and there's a cosine on the bottom. They cancel, and I get left with 1 over sine of t. And if you remember, 1 over sine of t, that reduces to cosecant of t. We are done. So what we just did was we reduced this down to this. So instead of messing with secant t divided by tangent t, we can just say that is equivalent to cosecant, okay? This is getting us warmed up for some more convoluted and more complicated simplifications that you can do with trig. We'll get there. When we get there, I will announce it, okay? Let's move on to the next one, okay? Doing the same thing, I can do tangent of t, right? You know what? Let me rewrite it. Tangent of t times cosine of t. Tangent of t is sine of t over cosine of t times cosine of t over 1. I can grab whatever I want and put it over 1. Okay? Okay. Again, we have something that looks exactly the same like we had over here. A cosine on the bottom cancels the cosine on the top. And this now reduces down to sine of t. So if you guys take a look, right, what we did was we grabbed this that probably might have been a little messy if we kept working with it, right, and turned it into something a little bit more compact. Okay? Okay. I'm going to get you guys to practice. Practice, practice, practice. Trig functions and any right triangle. So this goes back to the actual application. This is what we use our trig for, like in real life, okay? It is the SOHCAHTOA thing, okay? So if you remember, right, sine of some angle t is opposite over hypotenuse. Cosine of some angle t is equal to adjacent over hypotenuse. And then the tangent of some angle t is equal to opposite over adjacent. Okay? Now, I do have to explain this, right? That you guys see where my T angle is on my triangle, right? That is the basis for what we call opposite and adjacent. So you guys see that if this is my angle T, then this is my opposite. This is opposite of my angle T, right? Okay? If this is my angle T, then this is my adjacent. That's what's next to it, right? And then the longest side of any right triangle, the one that's opposite of the right angle, right? That is always going to be your hypotenuse. Okay? All right. So now, let's go and see what we actually use this for, right? So let's say we take a word problem here, okay? Let's say I went for a hike the other day, and I wanted to find the height of a tree. So I walked 30 feet away from the base, and I measured an angle of 57 degrees from the ground to the very top of the tree. What is my tree's height? Okay, and the hint that I give, and this is probably the hint that any science class is going to give you as well, is to draw a picture, right? So I'm going to draw my picture. I'm going to grab, here we go, here's my tree, right? Look at my tree. There we go, there's my tree, right? Okay, to the top of the tree, okay, is what I want to measure. I want to measure this. And what I did was from the base, I walked out, right, 30 feet. Let me go ahead and do a, okay, here I am. Okay, this is 30 feet. And this angle, hopefully you guys see the triangle already. This is going to be a right angle right here, right? This angle right here is 57 degrees. Okay. So hopefully you guys see the triangle already, right? Now, I want to measure the height. I want to measure this thing. I want to measure h, right? So I have an angle. I'm looking for its opposite. I have the adjacent. That's a tangent. You guys see that? So I want to do tangent of 57 degrees is equal to my opposite, h, over 30. Okay? Now all that's left to do is solve that out. Okay? I'm going to go ahead and do times 30 on this side, times 30 on that side. What happens on this side? My 30s cancel, right? So h is equal to 30 tangent 57 degrees, okay? Now, to actually get a number for that, okay, you can go ahead and use Desmos. Again, I love Desmos because Desmos is a decent enough calculator in its own right. I'm going to go ahead and do a split screen with me and Desmos here, okay? I want a number for that, 30 tangent 57, okay? 30 tangent 57. Now, I will have to warn everybody, okay, that for every calculator that handles trigonometric stuff, there are two modes, okay? One mode is if you're going to be using angles in degrees. And the other mode is if you're going to be using angles in radians, okay? Depending on what angle you're going to put in, you got to make sure you're in that mode, okay? In Desmos, if you go over here to the little wrenchy thingy, right? You open this thing up, you got all the stuff for the graphing. At the very bottom, you have radians and degrees, right? Right now, it's giving me the answer for radians. I don't want radians because the angle I put in is a degree. So I'm going to switch it to degree. There we go. Here's my answer. So my h is equal to 46.196 feet. And we are done. Okay. Okay. This is like I said, this is the actual application of our trigonometry, right? We haven't done any calculus yet, and we already are using this stuff for pretty hard-hitting stuff, right? Okay. What I got coming up next, some quick checks for everybody to try out, okay? Try them out. Try them out on your own. And then after that is select your questions. Okay. If there's any questions on the stuff that I covered, ask me during our quick check time or stop by the math lab when I'm there. Okay. Besides that, happy studying.